Welcome to Concurrent Programming in C++, and this is the first video in the series. So the first question is, what is concurrency? So you can think of concurrency as two or more activities happening at the same time. This is the very simple explanation. And if you like to relate it to your real life example, then you can think of one example as you are watching news on a TV and at the same time you are eating salad. So you are doing two things at the same time. This is the main concept of concurrency, and it applies to our computer programs as well. So there can be single core machines or multiple core machines. Now most of the machines should be multiple core, but for the sake of understanding, let's assume our machine has a single core. That is, it can execute one task at a time. But we can simulate concurrency if, let's say, this orange one denotes some task T1 and the green one is another task T2, then you can the machine can allot some time to T1, then pause it, then resume T2, then again pause and resume T1, and in this way both tasks T1 and T2 are running. So it will look like they are both running concurrently. So this is the scenario on single core machines because it has just one core. So it cannot run these two in parallel, but these two are running kind of concurrently because both of them are being done in parts. Now let's say we have dual core machine. So now we have two cores. So now two tasks can run in parallel. If we have more tasks, then again we have to divide this time slices. But if we have just two tasks, then they are really running in parallel. So this task T1 can run on core 1, task T2 can run on the second core. Similarly, more tasks and more core, you can imagine how would be the scenario. Now, what are the different concurrency models? So one model is multiprocessing, and the second one is multithreading. So let's see what is the difference between the two. So in multiprocessing, we have multiple processes. So this is process P1 and this is process P2. And within each process, just a single thread T is running. So this process has just one thread running and this process also has just one thread running. And if some communication is required between P1 and P2, then they communicate via inter-process communication. As compared to multiprocessing, let's see what is multithreading. So in multithreading, we have this, let's say this process P. So this is one process, this rectangular box. And within that process only, we can have multiple threads. In this example, we have two threads, P1 and T2. And the communication between these threads happen by shared memory. So here you see the communication was through inter-process communication channel, and here it's through shared memory. So there are pros and cons of both of these. So first, let's see what is the advantages of multithreading. One is that we call threads as a lightweight process. So these are very fast to start. And these have a low overhead. Whereas in the case of processes, OS needs to allocate many resources and it also needs to take care of security issues so that one process does not accidentally land into the space of other process. So it has processes have quite some overhead associated with them, which is not the case in threads. But there are some cons with multithreading as well, like these are difficult to implement, which will be see in other further videos. And these can't run on distributed systems, whereas in the case of processes, they can run on distributed systems very easily. And if required, they communicate by IPC. But here the communication mechanism is shared memory. Now let's see a hello world example of multithreading in C++. So you see this simple hello world example, and you would have seen this multiple times. So here is a function hello, which prints hello world. And in main, we can call this function hello. So this will run on single thread. Just here the main thread starts, it's called hello, it's sequential, it will still run in the same thread, and then finally this program will terminate. To make it multi-threaded, let's say we run this function from another thread. So here main thread starts, then we create a thread T and we initialize it with the function hello. So here T starts running. We don't need to call start to make it run. And here you see we call join. So this is called when we want the parent thread to wait for the child thread to finish. In this case, main thread is the parent thread and this T is the child thread. So if we don't call join, then main thread will continue its execution without waiting for this child thread to finish. And in this case, it's quite likely that main thread will finish before the child thread gets a chance to run. So you will never see this hello world in the output. So that's why join is required. So it's for wait for child thread to finish. And it need not be called immediately after this. Main thread can continue doing multiple things here, printing some output, doing some calculation, and finally when it's done with its task, then it can call t.join, and in the meantime this child thread can continue its execution, and if child thread finishes before the main thread reaches t.join, then it's fine, otherwise the main thread will wait. So let's see it also in code. So this is a simple hello world program. So let's move it to our function hello and call this hello from main. So there is no magic here, it will print hello world. So you see hello world is printed. Now just to confirm that we are in the same thread, you need to include this thread header when you want to use multi-threading in C++. This was introduced in C++ 11 standards. Now we have thread ID. So let's print the ID. And the same thing we can print inside the hello function. This will confirm that whether they are running in the same thread or not. So you see that both the thread IDs are same. Now we will make this multi-threaded. So here we will create a thread T, and we need to assign a function to it, the function that the thread needs to run. And now we don't need this because we will run this hello from a separate thread. Now, as I said, if I don't call join, you will see that this most likely this will not get a chance to execute and main thread will finish and the program will terminate. So let's run it. So you see it crashes the program here because this program has terminated, but this thread did not get a chance to execute. Now let's call the join. So once main thread prints it, we will call t.join, and the main thread here waits for t to finish. Now let's run it. So you see that here first this main thread's thread ID is printed because main thread creates the thread and asks it to run hello and then continues further. So most likely here the main thread prints its ID. Then this hello is called from child thread. It prints hello world, and it also prints the thread ID in which it's running. So you see this thread ID is different from this thread ID. So this confirms that we have two threads running here. So this was a hello world program for multi-threading. In the next videos, we will see more complex features of multi-threading in C++.